You're with Cape Talk.
You're with Cape Talk.
Every Friday, he joins us, the naked scientist, Chris Smith. How are you doing this morning, Chris?
I am in really good shape. How about yourself?
I am all right. There was a huge controversy in South Africa about 2-3 weeks ago, Chris. They discontinued anchovette, fish paste. I don't know if you're a fan or not. They discontinued it in South Africa. So I found a small town in South Africa. I got someone to go buy a whole lot. They shipped it to me, and I'm giving it away on air. So I could give one of those 9 jars that I have of fish paste to the best question on the Naked Scientist this morning. So you willing to be a little judge by the end of the next 16 minutes?
Can we do a rollover? I mean, if we don't like any of the questions this week, or we don't think they're up to scratch, can we roll it? How long have you got before the jar expires?
But that's the thing. I wouldn't want to keep. I want to get it. I want people to enjoy it. I don't want to appreciate like Bitcoin. I want it to people to enjoy it. So
Bitcoin's gone down the tubes. The value of Bitcoin has really gone down. So don't align your fish paste with the Bitcoin. All right. Well, let's have a go then. I'll grab my bit of paper and pen, and I will award marks out of 5. We have to choose an odd number, don't we? Because otherwise you get digit bias.
Okay. First question comes on the voice note. Let's have a listen.
Good morning, this is John here. My question to the Naked Scientist this morning relates back to the James Webb Space Telescope. What the possibilities would be for it to discover another one of the universal forces out there. We know that there are 4 at the moment: gravity, electromagnetism, and strong nuclear forces. Would the Space Telescope be able to perhaps identify or confirm another one, a 5th one?
The camera on the James Webb telescope turned on 2 days ago. Chris?
This telescope has been very, very long time in the making, as in decades. It launched on Christmas Day. They actually took off, and it's in position. It is a long way away from Earth on the other side of the moon in a point of gravitational stability, so it doesn't get pulled in one direction or the other. And the reason they've positioned it a long way away from us is because then it is as far away as possible from heat sources and other interference. Because this is an infrared telescope, and its role is to enable us to peer through clouds of gas and dust and other impenetrable muck in the universe that visible light would find it couldn't make its way through, because infrared and those sorts of longer wavelength radiations can see things that you can't see with visible light. And you need to park it somewhere really cold so that the detector and the mirrors and everything can cool right down, and then you minimise the noise and you get the most crystal clear pictures. Now, it's actually designed to enable us to look as far back in time possibly as we can. We'll be able to explore deep into the far reaches of the universe in terms of sort of pushing back the clock, because the universe is expanding and it's growing, and it's so big that some of the light reaching us now has actually taken billions of years to get here. So if you capture that light and you interrogate its source, you can understand what the thing that made the light looked like billions of years ago, when the universe was much younger and a different shape and a different composition. So it enables you to wind the clock back in time by seeing, and in so doing, you can test theories of the structure, the fabric, the shape of the universe, its composition in terms of what sorts of stars were there, what sorts of chemicals were in those stars, because you can begin to confirm or refute other theories about how those stars and the universe around them have evolved. So it's really powerful. It's not intended to do sort of fundamental physics in the respect of let's find another force. Its role is an observational role, but will enable us to test all kinds of theories about the evolution of the universe, what's out there, and how they relate to each other. And we should start to see the first images coming back on stream quite soon, I would think. I mean, certainly to prove the equipment's all working, and then it'll have an operating lifetime that will hopefully be as dramatic for astronomy as the Hubble Space Telescope was when it launched a few decades ago.
Let's go to another voice note.
Good morning. I have a question for Chris. The question relates to tidal movements and especially spring tides. Why is the spring low tide, be it new moon or full moon, for a given location in the south of Africa, why is the spring low tide almost always between 20 past 9 and 20 to 11. I'm not asking how tides work. I'm asking specifically why is spring low always around that time, and it's always been like that. Given that the solar year is not exactly 365 days, and given that a lunar cycle is not exactly 14 days, why does the spring low tide not shift over time in terms of its time in the day? It's very difficult for me to understand and explain.
This also raises the questions of what many physicists say, that time is also fundamentally not real. It's also a construct. How would you answer that question?
Well, that's a bit different than the clock ticking and recording the tides. And I know the questioner says, I don't want to know what tides are, but there may well be people who are wondering, well, actually, I don't really know what he means by a spring tide. So let's just clear that one up first. The Earth is a rocky thing, and it's covered in water. And the water can move, but the rock doesn't move. But around the Earth is a very big body, the Moon, which is gravitationally active. It's got mass, and therefore it's bending space-time around itself and pulling things towards it. Also in the universe, around us, in our cosmic neighbourhood, is our star, the Sun, which is 1,000,000 times bigger than we are, and that's very gravitationally active. That's why we're orbiting around it, because it's hanging on to us. The combined influence of the gravitational pull of the Moon and the Sun is what pulls water on the side of the Earth closest to those bodies towards them a bit, and causes the water to heap up there more than elsewhere around the planet. And as the Earth turns, it is turning through this bulge of water which is facing the Moon, and if the Moon and the Sun are in alignment, as you get with a new moon, or when you have a full moon, because that's when the Moon is on the opposite side of the Earth to the Sun and fully illuminated, you've got the gravitational pull along that axis, so you get bigger tides than when the Moon is pulling at 90 degrees to the Sun, and then you get what are called neap tides. You get smaller tides. And the bright ones listening will say, well, hang on, why are there 2 tides a day then? Because if it's just the Moon pulling water towards itself with the help of the Sun, why would there be 2 high tides a day? Because there would be one bump on the Earth's surface of water. The Earth takes 24 hours to go round, so why does it go high tide, low tide, low tide in every 24-hour period? And the reason for that is because when you're pulling the water on the Earth's surface closest to the Moon, the bit of the Earth's surface that's farthest away from the Moon is actually on the opposite side of the Earth. So you get a bump closest to the Moon in the water, but you also get a bump in the water on the far side of the Earth. So there are 2 bulges of water. And as the Earth turns, you turn through both of them, which is why you get one high tide, then you wait to the low tide, then you get another high tide, a low tide, another high tide, all within the same day. Now, the tide times that are published, if you look, you can find almanacs and so on that tell you when this process is going to be happening, because we understand pretty well the movement of water around the Earth, and we understand how fast the Earth's turning, and therefore when the tide should rise and fall. There are going to be local factors which are very powerfully influencing this process. So if you look at the almanac for different ports up a coastline, it will tell you that the high tide at one place will be X number of minutes ahead of the high tide at another place. And so this is owing to the effect of local geography and geology, movements of masses of water and so on. So there will be local effects on top of these sort of broad planetary effects. Now, why it should be centred on 20 past 9, I don't know the answer to that, and I don't know, I'd have to go and check that it is. But that is probably what's going on, that you've got the predictable function of the tides under the influence of gravity, and then you've got local factors which affect the movements of water and the dynamics of the water in particular geographies close to each other on the Earth's surface.
Gary in Franschhoek, your question to Dr. Chris?
Hi, good day, Chris and Lester. I just want to know, when my wife goes and wears in the night, she comes back, she's in the 60s, and all of a sudden she's like overheating. Why is that?
Sounds like menopause, Chris.
So you're saying, Gary, that she's having hot flushes at night, and not just of the lavatory itself?
No, I know menopause, but I mean, this is like, I think she should be post-menopause by now.
Well, there is this thing called the perimenopause, and the average age at which a person has the menopause is 55, and therefore there will be some people who are a bit older and some people who are a bit younger. But the perimenopause, which is as you go towards the point where periods actually stop, there is some imbalance or flux in hormone levels. They can rise and fall chaotically, and it does take the body a while to settle into a new rhythm with where you're not having menstruation and you haven't got those same cycles of hormones, and it takes a while for things to settle down after that's happened. So I would say if these symptoms have always been happening around this sort of time for a long period of time, that could well be menopause. I think Lester's right. But if this is a new thing, if people begin to get night sweats out of the blue, it's a new thing, this could be something else going on. So if this is not something that can be accounted for on the basis of age, it's not something that's been a chronic thing that started after a certain age and has been there and not changed, it's just annoying, then it's probably fine. But if it's a new thing that suddenly started to happen and you wake up at the night and you're bathed in sweat and feeling very hot when you shouldn't be, that probably warrants investigation, because there are a range of reasons why that could happen, ranging from infectious to other ones. So I think it will depend on what the underlying sort of history is here as to how you should pursue it and whether you should get more done or write it off as this is just age.
Thanks so much, Gary. Remember, Dr. Chris Smith can answer your science and natural history related questions. Any personal medical questions, rather go to your doctor. Bastian in Wellington, good morning.
Hi, good morning, Lester. Morning, Chris. I have a question regarding the James Webb telescope as well. They parked it on Lagrange point 2 to get away from the solar radiation on the dark side of the moon. If that's the reason, why didn't they just park it or land it on the dark side of the moon? Surely that would have been simpler.
Well, although Pink Floyd had a very successful album called The Dark Side of the Moon, and it led everyone to think that it's dark as in there's no sunshine there, that is not actually the case. That side of the moon is dark to us because it's mysterious. We can't see it because the moon always points the same face towards us and keeps one face pointing away from us because of a quirk of the fact the moon is turning at the same rate that it's orbiting. So you end up with the same face always pointing towards us. But that does mean that the so-called dark side of the moon periodically is in the full glare of the sunshine. And so that wouldn't be a good idea because that part of the moon's surface is going to get sizzled and it's going to get quite a lot of radiation bouncing back off of it, which would be problematic for your telescope. But it's a really good question in the sense that scientists are saying, well, look, there are some parts of the moon's surface that the sun never does shine upon, and they are really very cold. They point out, they can see very dark bits of the universe, and they're minus 200 degrees or so all the time. And so people are talking seriously about the concept of erecting space telescopes there, including space telescopes that use special ionic liquids. These are liquids with very extraordinary properties, but you could use silver ionic liquids and then have a mirror that was actually a liquid, but one which is still a liquid at about minus 200 degrees, which is the surface it would be in a crater on the moon's surface. And then you'd have natural cooling. It'd be dark and stable temperatures all the time, nice and radio silent, and no light pollution. And you could then have a mirror that was very easy to tune with a fraction of the gravity that we've got on Earth. Because the other problem we have with big telescopes on Earth is that the gravitational pull of the Earth distorts the mirror. And you've also got atmosphere you have to compensate for, whereas on the moon there's no atmosphere and lower levels of gravity. So it might well be that they do land and put a big telescope on the moon that can see dark parts of the universe, but it wouldn't be a good idea to put the James Webb Space Telescope on the moon's surface, and certainly not on the dark side of the moon, because it's actually quite bright at certain times and therefore going to have a lot of radiation that would hit the telescope, and that would distort the images.
Chris, I think that's about what we have time for today. You know, we've had a truncated and a short and naked scientist. We're running out of time, and I've asked you to maybe pick your favorite question. That person, if they want, gets a jar of fish paste.
Well, I think the last question was very insightful in the sense that it enabled us to talk about various aspects of the moon and lunar physics, but also elaborate on what scientists are thinking of doing in the future with respect to astronomy from the moon's surface. So I would say if Bastian likes your particular fish paste, he may not. I mean, I would ask him, because you don't want to waste it, do you? And I would say if he wants it, then he would be my choice. But if he doesn't like fish paste, then let's roll it over till next week.
What's your thoughts? You're a fish paste fan?
I don't mind it, but I'm more of a meat paste sort of. I quite like pate, and so I'd probably roll the jar over and say let have some other deserving candidate have it.
I'm a terrain person myself. Chris Smith joins me again next week for The Naked Scientist. Thanks so much, sir.
You're welcome. See
Looking
you soon.
forward to next week. Bye-bye.